So now that we've had a little bit of background about how these different microbial processes occur, we're going to talk a little bit about what we're doing to figure out what's going on in the estuary and kind of what's going on in our backyard. So the first objective of our research is to figure out what the geochemical processes are. So is sulfate being reduced, where it's being reduced, and kind of what's going on. So where these different, we want to figure out where within the sediment sulfate is being reduced and what's going on there. The second part of our project is to figure out if there's potential for the mercury to be changed into the bioaccumulative form, which is methylmercury. So is methylmercury being produced in the sediment? So that's kind of the whole point of this. So this is kind of the way that we think about how methylmercury is created. So there's a bunch of different situations in different aquatic systems where methylmercury can be produced. And so if you think about it, so there can be a lot of organic carbon, which is something that the sulfate reducing bacteria need to live. But if there's too little sulfate, it creates a situation where there's low methylmercury and the fish are obviously happy. And there's a lot of other situations in the far extremes, like if there's excessive organic carbon and excessive sulfate, counterintuitively, there's not very much methylmercury because it creates a situation where excess sulfate creates a toxic environment for the bacteria, which isn't good. And so all these extremes actually create situations where there's low methylmercury, which is kind of counterintuitive. So the situation that is most important is when there's kind of, this is kind of odd, but just the right amount of sulfate and organic matter for methylmercury to be produced in the sediment. So this is where we have the warnings where the fish can be contaminated with methylmercury, where these situations are kind of the perfect storm of organic carbon and sulfate. So this is a picture of the St. Louis River Harbor or estuary that we're interested in looking at. And this is kind of our conceptual model. So I talked about how there's kind of different situations where there's high organic carbon and high sulfate and low organic carbon and low sulfate. So as you go down the river, downstream, like we talked about before, it goes, the sulfate goes up and the organic matter goes up, and it eventually gets diluted as you get closer to the Lake Superior mouth. And so we're trying to figure out where in the harbor, if any, is there a spot where methylmercury is being produced, and if there is kind of that hot spot or that area that might be bad. So what we did next, after we figured out where this we were thinking about this conceptual model, is where we're going to go and take samples. So the first thing that we did is we wanted to get samples that were along that high organic carbon, high sulfate, and low carbons and low sulfate gradient. And so we picked sites along the river. And the other thing that we took into consideration is, instead of trying to get a sample that was only representative of right exactly where we're taking the sample, we used aquatic habitat zones that were created by the St. Louis River Alliance. So for example, the sheltered bay that's in the lower end of the picture is representative of quite a few spots around the harbor. So we can say, if we take a sample at this spot, it might be kind of representative of other areas, so it's not just really, really localized. So we tried to get sites that were representative of about half of the estuary, with just doing three different areas.